What if the solid world around you, this screen, your own hands, isn't as solid as it seems? What if, at its very core, reality is just a shimmering cloud of pure potential? For nearly a century, a secret has been hiding in plain sight within physics labs. It's this: the simple act of looking at something, of measuring it, doesn't just see reality, it changes it. The universe at its smallest scale behaves completely differently when it's being watched. This forces a question that sounds like science fiction, but is absolutely scientific fact. Does reality only exist when you look at it? The answer will unravel everything you think you know about being a separate observer in a fixed world. Because the truth is, you are not just a witness to the universe, you are a participant. This is a journey from a question to a revelation. We're going to explore the quantum evidence, and I promise you, by the time we complete the loop and return to this very question, your understanding of what it means to look, to be, and to exist will be fundamentally transformed. Let's begin where all quantum mysteries start, not with solid things, but with a world of beautiful, blurry possibility. The blurry world of potential. So, if reality doesn't just sit there, solid as a rock, what is it actually doing? To understand that, we need to forget everything we think we know about how things behave at their most fundamental level. Forget the idea of a tiny, hard electron orbiting a nucleus like a planet around a sun. That model is a complete lie. The quantum world isn't a world of things. It's a world of maybe, a world of potential. Think of it like this. Imagine a single perfect dice spinning in midair. Before it lands, what number is it? It's not a 1, it's not a 6. It's a blur of all possibilities at once. In the quantum realm, this isn't just a metaphor. This is literal. Physicists call this state superposition. An electron isn't in one place. It exists as a wave function, a cloud of probability, a mathematical description of where it could be. It's everywhere it's possible to be, all at the same time. This is the first and maybe the most important quantum truth. Before anything happens, before we look, before we measure, reality is fundamentally fuzzy. It's not made of particles. It's made of potentials. Now, your common sense is probably screaming right now. That's impossible. My chair is solid. I'm solid. And you're right, at our scale. But this blurry quantum behavior has been proven again and again in labs around the world. One of the most famous examples is the double-slit experiment. When you fire tiny particles, like electrons, at a barrier with two slits, they don't form two neat lines on the other side, like bullets would. They form an interference pattern, a series of stripes, like waves interfering with each other. The only way this happens is if a single electron goes through both slits at the same time. It behaves like a wave spread out in space, not a single point. This is the universe's default setting, a shimmering, buzzing haze of could be, a reality that hasn't yet made up its mind. It feels strange because we live in a world that has already made up its mind. We experience the result, not the process. But this blurry state of potential is the foundation of everything. It's the ocean before a wave rises. It's the silence before a note is played. And it leads to the inevitable, spine-tingling question, what forces the universe to finally choose? What collapses all that potential into the single, solid world we see? What happens when we look? The Great Collapse. So, we're left hanging in that blurry state of pure potential. That electron is a probability wave, existing in a superposition of many places at once. It's the spinning dice, forever in midair. But obviously the dice does land. The world we experience is sharp, definite, and solid. So what happens? What forces the quantum world to make up its mind? This is the moment of the Great Collapse. It's the single most dramatic event in the quantum world. Remember that wave function, the mathematical description of all those possibilities? The moment we ask a specific question, the moment we set up a detector to see which slit the electron goes through or where it actually is, something incredible happens. That spread out wave of potential collapses instantly. It chooses. It goes from being a cloud of maybes to a single definite here. It's the exact moment the spinning dice gets slapped down on the table. The blur is gone. It's a 6. No going back. This is the infamous measurement problem, the core mystery that has puzzled physicists for a century. The act of measurement itself, the act of looking, seems to force nature to pick a state. Now, you might be thinking, okay, so my equipment is just bumping into it, forcing it to settle. But here's where it gets truly bizarre. In the double-slit experiment, when you place a detector at the slits to observe the electron's path, the interference pattern vanishes. Just by gathering that one piece of information, the electron stops behaving like a spread-out wave and starts behaving like a single localized particle. It's as if the electron knows it's being watched. This is the observer effect in its most profound form. It's not that we're physically disturbing it with clumsy tools. It's that the very act of obtaining information, of creating a definitive record, seems to trigger the collapse. Let that sink in. The universe at its most fundamental level exists in a state of openness, of potentiality, until an interaction occurs that extracts a specific fact. Before the measurement, the particle's properties like position are indeterminate. They aren't just unknown. They are literally not yet decided. This is our first quantum leap in understanding. Reality isn't passive. It's responsive. It's a conversation. We ask a question, "Where are you?" And reality answers. But in answering, it gives up all its other possible answers. So is it our consciousness? Is it the human mind that causes this collapse? That's a tempting thought, but it leads us down a strange path. If a human has to be there to look, what about a camera? What about a rock? When does a measurement truly happen? This question, what exactly qualifies as an observer, is the crack in the door that leads to an even deeper truth about how the entire universe interacts with itself. And that is where our journey gets truly interconnected. Spooky connections. So now we have a picture of a universe that waits for a signal, a measurement, to snap from possibility into reality. But this creates a new, even deeper mystery. If particles are separate, independent things, how does this even work? The answer will shatter your idea of what separate even means. Welcome to what Einstein called spooky action at a distance. Welcome to the world of quantum entanglement. This is where the quantum world moves from being strange to being downright miraculous. Entanglement is a connection faster than light, a bond that defies space and time itself. Here's how it works. Under the right conditions, you can create a pair of particles that are intrinsically linked. They become a single, unified quantum system no matter how far apart you move them. They could be in the same lab or on opposite sides of the galaxy. Now remember superposition from Chapter 1? That blurry state of maybe? Let's say you entangle two electrons. Their spin, a quantum property like a tiny compass needle, isn't defined. Both particles are in a superposition of spinning up and down at the same time. Here's the spooky part. The moment you measure one of them and its wave function collapses, the moment you see its spin is up, the other particle's wave function collapses instantaneously. It will always be measured as spinning down. It doesn't need time for a signal to travel. The connection is immediate. It's as if the universe has a hidden, faster-than-light phone line. Einstein hated this. He called it spooky because it seemed to violate the universal speed limit, the speed of light. How could one particle possibly know what happened to the other millions of light years away without any communication? For decades, this was a philosophical debate. Then, in the 1960s and 70s, a physicist named John Stuart Bell proposed a way to test it. Bell's theorem created a mathematical way to distinguish between a universe where particles have hidden, predetermined states, like a magician's trick, and a universe where this spooky action is real. The experiments have been done, repeatedly, and the results are clear. Einstein was wrong. There are no hidden variables. The particles are truly connected in a way that transcends space. This non-locality is a fundamental feature of our universe. Think of it like this. Imagine you have a pair of magical gloves. You put each one in a separate, indestructible box. You have no idea which box contains the left glove and which contains the right. That's the superposition. Now, you take one box to the farthest star you can find. You open it. You find the left glove. At that exact instant, you know with 100% certainty that the box back on Earth contains the right glove. But in the quantum world, it's not that you know, it's that the other glove becomes the right glove at the exact moment of your observation. Before you looked, both were potentially left and potentially right. This isn't just a laboratory curiosity. This is the principle behind cutting-edge quantum computing and quantum cryptography. We're starting to harness this spooky connection to build machines and create unbreakable codes. So what does this tell us? It tells us that the universe, at its core, is not a collection of isolated billiard balls. It is a deeply interconnected web. The very idea that you are here and I am there as separate entities is an illusion that emerges from a deeper, unified reality. We've seen that particles exist as potential, that observation collapses that potential, and that particles can be mysteriously linked. This forces us to ask the biggest question yet. What is the observer really? If the universe is so deeply connected, is any measurement ever truly isolated? The answer will change your role in the cosmos from a spectator to a participant. The participatory universe. We've arrived at the quantum crossroads. We've seen particles exist as probability waves. We've witnessed the great collapse of measurement. We've felt the spooky connection of entanglement. This brings us to the ultimate question we've been circling since the beginning. If reality needs an observer to collapse into existence, what exactly counts as an observer? Does it require a human mind, a conscious being? This is where we make our final quantum leap, and the answer is both simpler and more profound than you might imagine. The key lies in a process called quantum decoherence. This is the missing piece that solves the measurement problem without needing any magic consciousness. Think of it this way. In a perfectly isolated lab, an electron can maintain its delicate superposition. It can spin both up and down simultaneously. But our universe is not isolated. It's noisy. It's filled with light photons, air molecules, and radiation, a constant storm of interactions. Now, imagine our spinning electron is like a perfectly still, balanced spinning top. This top represents its coherent quantum state. The moment this top is placed in the real world, the moment a single air molecule bumps into it, it begins to wobble. It loses its perfect balance. That wobble is decoherence. With every bump from a photon, every interaction with any other particle, that delicate quantum superposition leaks information into the environment. The quantum weirdness gets washed away by the constant chatter of the universe. The wave function doesn't collapse because a human looks at it. It collapses because the environment is constantly looking, constantly interacting with it. This is the pivotal shift in understanding. The observer isn't a conscious mind. The observer is any interaction that makes a quantum event irreversible, that creates a permanent record in the environment. A photon bouncing from an atom into your eye is a measurement, but so is a photon bouncing from that same atom into a rock. The rock becomes part of the measurement chain. The universe is constantly measuring itself through countless trillions of tiny interactions every second. This is why the world appears solid and definite to us. Quantum decoherence happens almost instantaneously for any object larger than an atom. The quantum weirdness is still there, at the very foundation, but it's being continuously collapsed by the environment itself. We are not outside observers of a fixed universe. We are embedded within it. We are part of the environment that is constantly performing these measurements. Our consciousness emerges from this physical, participatory process. We are not the magicians who collapse reality with our gaze. We are the audience, the stagehands, and the stage itself, all participating in a cosmic performance that has been ongoing since the beginning of time. This transforms the entire question. It's not, does reality exist when we look at it? The deeper truth is that reality crystallizes through relationship, through touch, through interaction. We are not passive witnesses. We are active participants in a universe that is fundamentally relational. The act of looking is just one special case of a universal principle, that existence is defined by connection. So, we arrive back where we began, at that seemingly simple question. Does reality only exist when you look at it? After this journey, you now hear that question with new ears. The answer is both humbling and empowering. No, reality doesn't blink on and off like a light switch when you open your eyes. The truth is far more magnificent. That solid world you see was never truly solid. It was always a sea of potential, a cloud of maybes, waiting for a relationship, a connection, a moment of interaction to bring it into focus. The look isn't magical, it's fundamental. It's any moment the universe touches itself and makes a choice. A photon hits your retina, an atom bumps into another, and in that touch, potential becomes real. This means you were never just a spectator on a fixed stage. You have always been a participant in the cosmic dance. Your attention, your actions, your very presence is part of how the universe continuously creates itself. So now I leave you with a new question, one you couldn't have truly understood before this loop began. If looking is a form of touching, and touching creates reality, what kind of world are you helping to bring into being with your focus? Every moment you are collaborating with existence. What will you choose to make real? If you feel your perception shifting, if you see the shimmer of potential behind the solid world, then you understand. This is just the beginning. The rabbit hole goes infinitely deeper. Subscribe now, and let's continue to collapse reality together. Until the next loop, stay entangled.